In this video, we're going to look at quadratic and rational nonlinear inequalities. Let's look at the quadratic inequalities first. So first step is to get a 0 on the right hand side and factor the quadratic expression on the left hand side. And then figure out where does each of the factor become 0 and then make the sign chart. Let's look at an example. First one, solve x squared minus 13x plus 12 less than equal to 0. So solving it means we are looking for the values of x that will make the left hand side negative. So for that, I already have a 0 on the right hand side, which is perfect. I'm going to start by factoring the left hand side. Two numbers that multiply to give me positive 12 and add up to give me negative 13 are negative 12 and negative 1. So x minus 12 and x minus 1 are the factors. Now figure out where does each of the factor become 0. This factor becomes 0 at x equals 1, and x minus 12 becomes 0 at x equals 12. So now these are my different zones where I need to pick the test values and make the sign chart for the inequality. So if I pick a number x equals 0 and to the left of 1, if x is 0, then the inequality is positive. Between 1 and 2, we can pick 1.5. If I pick 1.5, then if x is 1.5, then my first factor will be negative, and the second factor will be positive. Positive times negative is a negative. And if I pick, this is a 12. If I pick, this is 12, this is 1. If I pick 13, both of the factors are going to be positive, and my product will be positive. So we have an equal sign here. Be careful about that. If there's an equal sign, we will include the endpoint. So in this case, we wanted our inequality to be less than 0, means negative, which is happening between 1 and 12. And we are going to include both 1 and 12 because there is an equal sign. If there was no equal sign, we would not include 1 or 12. We would put parentheses around in that case. But because we have the equal sign, we use brackets. Next example, solve 6x squared plus 5x minus 6 greater than equal to 0. Okay, the first step is I need to go ahead and factor this, and I use bottoms up method to factor it. I'm looking for two numbers that multiply to give me negative 36, which is the product of a and c, and the two numbers that add to give me b, which is 5, positive 5. My numbers are 9 and negative 4. They multiply to give me negative 36. Add to give me 5. Divide both of these with the 6x to now simplify. This is going to be 2x plus 3. This is why this method is called bottoms up, 2x plus 3. And the second factor simplifies to 3x minus 2 greater than equal to 0. Now let's go ahead and mark our number line. The first factor where the expression becomes 0 is at 2/3. Second factor is negative 3/2. Because this factor becomes 0, 2x plus 3 is 0 when x is negative 3/2, and 3x minus 2 becomes 0 when x equals 2/3. Okay, so now we're going to pick the test values, test points in between these zones, and find out the sign of the left-hand sided expression at that particular x value. Again, you don't need to worry about what value does it take. We just need to worry about the sign, because if you pick a different test value, your expression will take a different value. In between negative 3/2 and 2/3, we can pick 0. It's always easy to pick 0. As long as it's not one of your boundary points, you can always pick 0. It's easier to do calculations with 0. If x is 0, my first expression is positive, second is negative, so the product will be negative. To the right, I can pick x equals 1. Again, it doesn't matter what your answer is when you plug that number. only thing that matters is what's the sign. Is it positive or negative? SIGN sign. Okay, so x equals 1. If I plug x as 1, my both parentheses will be positive and product will be positive as well. And if I pick x as negative 5, let's say, that's going to give me negative 10 plus 3 is negative 7, and negative 15 minus 2 is negative 17. The product will be positive. So we wanted our inequality to be greater than or equal to 0, which is happening here and here. We also wanted it to equal 0, so we're going to include the endpoints. So my solution in this case would be negative infinity to negative 3/2 union 2/3 to positive infinity. And that's our solution for this quadratic inequality. See another example. X squared minus 20 greater than equal to 0. First step is to factor this polynomial. Second step is to figure out where does each of the factor become 0. The first factor becomes 0 at negative square root of 20. The second factor becomes 0 at positive square root of 20. Notice the square root of 20 is between 4 and 5. So it's like 4.4, something like that. This is negative. Okay. In between, we can pick the 0 as a test value to see the sign of inequality. If I pick x to be 0, I get something negative. To the right, you can pick any number larger than square root of 20. I'm going to pick as 10. If I pick x as 10, both of these will be positive factors and product will be positive as well. And to the left of negative square root of 20, we can pick x as negative 10. Negative 10 plus square root of 20, that's going to be a negative number. A negative 10 minus square root of 20 is also a negative number. Product of a negative and negative number will be positive. Now go back and look over here. You wanted your inequality to be greater than equal to 0, means you wanted it to be positive. So my solution would be all the values where it is positive, including the endpoints. So negative infinity to negative square root of 20 with parentheses, union 20 square root of 20 to infinity. Okay. Next example, we're going to look at some rational inequalities. Again, our goal will be to get a 0 on the right hand side for rational inequalities. I want to get a 0 on the right hand side first. If you already have 0, then figure out where does the numerator become 0 and where does the denominator become 0. You'll have to be extra careful in these problems because even if you have an equal sign, you don't want to include the number that makes your denominator 0 because then that makes your function undefined. Nice thing about this first problem number 4 is my inequalities, both numerator and denominator are already factored. So the numerator becomes 0 when x is 2. Numerator becomes 0 when x is negative 3. Denominator becomes 0 when x is 2. Let's figure out the test points, test values. In between, I can pick x as 0. If x is 0, if I plug x as 0 in here, my left-hand side becomes 3 over negative 2, which is a negative number. And to the right, I can pick x as 4. 4 plus 3 is positive. Divided by 4 minus 2 is also a positive. Divided by positive is going to be a positive. And to the left of negative 3, I can pick x as negative 5. Negative 5 plus 3 is negative 2. Negative 5 minus 2 is negative 7. Negative divided by negative is a positive. So we wanted our inequality to be greater than 0 only. There was no equal sign, which is happening. So it's greater than 0 between negative infinity to negative 3, union 2 to infinity. Okay, your boundary points, right? So everywhere here and everywhere here, my inequality is positive. Now I'm going to add a little twist to it. What if we had an equal sign? How would your answer change? If you had an equal sign, we would say negative infinity to negative 3 with bracket, but we would never put bracket around 2, even if you have an equal sign. because if x is equal to 2, your inequality does not equal 0. It actually becomes undefined. Okay. Next example, 6 over x is greater than 4. So our first step is to bring the 4 to the left-hand side and try to factor it out if possible, or combine to get a single numerator and single denominator. So this becomes 6 minus 4x greater than 0. Now where does the numerator become 0? At x equals 0. Where does the numerator become 0? When 6 minus 4x is 0, which is 6 equals 4x. 6 over 4 equals x, which is 3 halves. So numerator becomes 0 at x equals 3 halves. And denominator becomes 0 when x is 0. Okay, again, I'm going to include an equal sign here to make it more fun, so that we be careful about including 0 or not. Right, so I can pick my test points now. In between, I'll have to pick x equals 1. You want to pick a nice number in between. Of course, you can pick like x equals 1.2578, whatever you want, but picking nice numbers makes calculations easier. If x is 1, the left-hand side would be 6 minus 4, which is 2, divided by 2. It's going to be positive. And to the right of 3 halves, which is 1.5, I can pick x as 3 or x as 4, x as 5, whatever you want. Doesn't matter which number you choose. The only thing that matters is the sign. So this can be 6 minus 20 in the numerator, which is a negative number, divided by 5. It's going to be a negative number. Negative number divided by positive number is negative. To the left, we can pick a negative 1. So 6 plus 4, which is positive, divided by negative would be a negative number. Now let's go ahead and think. We do have an equal sign. That means, and it's a greater than equal sign, means we want it to be positive, but we don't want to include the number that makes a denominator 0. So we cannot include 0 in our solution, but we can include 3 halves. So bracket around 3 halves and parentheses around 0. See one last example. This one looks very tedious, but let's see. I'm going to go ahead and start factoring the numerator. I can first pull out a 3 from the numerator here, which is going to be 2x squared minus x minus 1, and x squared minus 2x minus 8 less than or equal to 0. Let's go ahead and factor the inside expression. Two numbers that multiply to give me negative 2 add up to give me negative 1 are negative 2 and 1. Divide them both with the 2x and 2x. So I'm using bottoms up method to divide them. So my factors become x minus 1 and 2x plus 1 divided by two numbers that multiply to give me negative 8 add up to give me negative 2 are x minus 4, x plus 2. Now let's go ahead and we can go ahead and divide both sides with the 3 if we want, or we can just leave that 3 over there. It's a positive number. It's not going to make any difference if you multiply or divide with multiply with the number 3. It's not going to change our sign. So it doesn't matter. You can leave it there or you can get rid of the 3 from there. So numerator, there's a bunch of boundary points here. This factor becomes 0. X minus 1 becomes 0 when x is positive 1. 2x plus 1 becomes 0 when x is negative 1 half. Make sure you mark them in the order they are supposed to be on the number line. X minus 4 becomes 0 when x is 4, positive 4. X plus 2 becomes 0 when x is negative 2. All right. Now we got to pick our test values in between and see what is the sign of the expression on the left-hand side that I get. In between, it's easier to pick x as 0. If I pick x as 0, this expression is going to be, if I choose x to be 0, this is going to be a positive expression. If I choose x to be 0, it's going to be a positive expression. because I'm going to have 3 times a negative number times a positive number divided by a negative number times a positive number. Negative divided by negative will be positive. Between 1 and 4, we can pick x equal to 3 or x equal to 2. If I pick x as 2, I would have 3. 2 minus 1 is positive, and 2 times 2 plus 1 will be also positive. 2 minus 4 is going to be negative, and 2 plus 2 is going to be a positive. So this is going to be, it's going to end up to be a negative number. If I choose x as 5, I will have 3 times 5 minus 1 is positive. 5 times 2 plus 1 is positive. 5 minus 4 is positive. 5 plus 2 is positive. Altogether, it turns out to be positive. Between negative 2 and negative 1/2, we can pick x as negative 1. So 3 times negative 1 is a negative number. Negative 2 plus 1 is a negative number. Negative 1 minus 4 is a negative number. Negative 1 plus 2 is going to be a positive number. So we are doing positive divided by negative. It's going to ultimately be a negative number. To the left of negative 2, we can pick x equals negative 3. 3 times negative 3 minus 1 is negative. That would be again negative, negative, negative. And all together, it's going to be a positive because I'm dividing negative times negative on the numerator, negative times negative in the denominator. And we wanted this inequality to be less than equal to 0. Keep this in mind. What did you want? Did you want it to be greater than equal to 0, greater than 0, or less than equal to 0, or less than 0? So where is it negative? And do we include the endpoints? So you got to be careful. Between negative 2 and negative 1/2, it is negative. But we cannot include negative 2, but we can include negative 1/2. Other place it's negative is between 1 and 4. We can include 1, but we cannot include 4 because you have to exclude the numbers that make the denominator 0. Those numbers will not make your inequality negative or equal to 0. They're actually going to make it undefined. Hopefully that helped.